Welcome back, friends. So now we are ready for remainder theorem. What remainder theorem says is, let Px be any polynomial with degree n greater than or equal to 1 when Px is divided by a linear polynomial of the form x minus a, then P of a is the remainder. Okay, P of a is the remainder. So the remainder theorem says if Px is any polynomial with degree n greater than or equal to 1 when it is divided, right, by a linear polynomial x minus a, then P of a is the remainder. See, in our earlier video, when we saw the division, we took an example of the polynomial 3x squared plus x plus 1. We divided it by x plus 1. Okay. So, x plus 1 can be written in the form x minus minus 1. Okay. So, we are now going to see a practical application of the remainder theorem. So, x plus 1 can be written as x minus minus 1. Now, let us apply remainder theorem. Px is 3x squared plus x plus 1. So, when we divide 3x squared plus x plus 1 by x plus 1, we should get remainder which is equal to P of a. Okay. So, as I said, x plus 1 can be written as x minus minus 1. Hence, a is equal to minus 1. So, now find P of a. P of a is equal to 3 into minus 1 the whole square, which is 1. Right. So, you get the first term as 3 plus x. So, instead of you substitute minus 1, it becomes 3 minus 1, 2. And then you have a constant plus 1. You get remainder as 3. This is the same remainder that we got when we divided. Okay. So, this is what remainder theorem says. Right. Let us see how to prove this theorem. Let us assume Px is a polynomial. Right. And we are dividing it by a linear polynomial of the form x minus a, where a is any constant, any real number. Okay. Then how can we write Px? See, as we had seen earlier, a dividend can always be written as quotient into divisor plus remainder. Correct? Quotient into divisor plus remainder. So Px can be written as, Px is a polynomial, correct? So Px can be written as Px equal to x minus a into qx, where qx represent the quotient, which again is a polynomial, correct? So quotient is also a polynomial, right? Because we are talking about polynomial division. Hence, the quotient and remainder will be polynomials. So P of x can be written as x minus a into q of x plus r of x. Okay. Now, what is the degree of x minus a? It is 1, right, which is the divisor. Now, the remainder cannot be greater than the divisor, right? So, the degree of the remainder cannot be greater than the degree of the divisor. So, the degree of divisor is 1. Hence, here the remainder r of x, the degree of r of x is 0, which means r of x is a constant. It is not a polynomial. Okay. So, let us say r of x is, it is nothing but it is a real number r. Okay. So, now P of x can be written as x minus a into q of x plus r, which is a constant. Right. So, the remainder, when you divide a polynomial with a linear polynomial, the remainder is always a constant. Okay. Let's say r. Now, what is P of a? Right. Now, let us evaluate P of a. P of a equal to, wherever you find x on the right hand side, you have to substitute with a. Okay. So, P of a is, instead of x minus a, you can put a minus a into q of a, right, plus r. Right. What is a minus a? It is 0. So 0 into q of a plus r. 0 into q of a, 0 multiplied by anything is 0. 0 plus r, which is equal to r. So p of a equal to the remainder r. Hence the theorem is proved. So the remainder theorem says that let px be any polynomial with degree greater than or equal to 1, and let a be any real number if px is divided by the linear polynomial x minus a, then the remainder is pa. This is the statement. Okay. So you please listen to this video couple of times, go through the proof that I explained, note it down on a piece of paper, right? And then we can ponder on these things. Okay. See, if let us assume we had seen about factors in the 8th standard, right? So if there is a number, then there will be factors, right? We had also used identities. So you know, we used to solve expressions of the form x squared plus ax plus b. Okay, we used to solve such expressions, and we used to factorize these expressions. You know, this we had seen in our 8th standard. Okay, in algebraic expression we had seen this. Now similarly, let us assume that x minus a is a factor of px. Then what does it mean? When it is a factor, then the remainder will be equal to 0. Okay. So x minus a is a factor of p of x if p of a is equal to 0. Or in other words, a is a 0 of the polynomial p of x. See, we had learned about zeros earlier, right? This is where zeros, the definition of zeros are useful. Okay. So if x minus a is a factor of p of x, provided p of a equal to 0, because p of a as per the remainder theorem is the remainder that we get when we divide a polynomial with x minus a, and if x minus a happens to be a factor, the remainder will be 0. 3 is a factor of 6. When you divide 6 with 3, the remainder is 0. Okay. So if x minus a is a factor of the polynomial p of x, then p of a equal to 0. Now by definition, x minus a is a factor of itself. X minus a is a factor of x minus a, right? Hence, a is a 0 of x minus a as well, right? So if a is a 0 of x minus a, then a also will be a 0 of p of x, provided x minus a is a factor of p of x. Alright, great. So you wait for my next set of videos. You are actually ready to try up to exercise 2.3, right? Exercise 2.1, 2.2 and 2.3 you are ready. Please go through the examples. If you listen to these videos, right, very carefully, right, I'm 100% sure that you will be able to solve the problems without much difficulty, right? And in case if you have any doubts during your studies, you know the email ID to which you should email your doubts. It is askmentorguru@gmail.com. Alright. So let us all learn well. Let us all perform well. Okay. Again, as I used to tell you, mathematics is very simple. All we have to do is, planned learning, little bit of practice, little bit of discipline. That's all we need. Mathematics will become very, very easy for us. We can score good marks in mathematics. Okay. So I am here to help you. Please send me your doubts. I will definitely clarify your doubts. Okay. So thank you very much. Please share it with your friends so that your friends can also learn. Please subscribe and press the bell button. Thank you very much. Thank you for your time. God bless you. And we will meet again in our next set of videos. Thank you. Bye.